Welcome to solverfy.
For this question, we want to find how many neutrinos are passing through a ceiling at a particular angle, right? But to do that, we will first need to find out how many neutrinos are being generated per second. We know that from a previous question, the rate of proton consumption is as follows, right? It's the amount of protons that is consumed per second, and we know that for every 4 protons consumed, 2 neutrinos are produced, right? So the number of neutrinos that are produced, we just have to multiply this by 2 over 4, right? 2 neutrinos per 4 proton. We should get 1.712. And so this is the rate at which neutrinos are being emitted from the sun, right? Radially in all directions. But of course, not all will be captured by our ceiling, and it will depend on the area, right, of the ceiling. And in this particular case, we are given the area is 180 meters square. What we have to do is we take a ratio of this particular area over the entire surface area of the sphere, right, in which the radius is the distance from the sun to the earth. This sphere is the sphere in which the neutrinos are being ejected out uniformly, and so the small area of the ceiling over here as a fraction of the entire surface area of the sphere will give us the proportion of neutrinos that are captured by our ceiling. So the amount of neutrinos that is passing through, we take the total number of neutrinos, multiply that by the fraction, right, as previously mentioned. So this is the fraction over the entire surface area, that is 4 pi times r square, and the r is the distance from the sun to the earth, that is 0.496 times 10 to the power 11 meters square. But we have to take note that we are also given that the ceiling, right, is at a latitude of 44 degrees. So it is not directly perpendicular to the ceiling. So you have to add a cosine factor to account for the angle difference. And that will be cosine 44 degrees, right? This is mentioned in equation 21.1. So after including this cosine factor, you have to account that we are talking about 1 hour in total, right? So we have to multiply this by the number of seconds in an hour, so that is 3600 seconds per hour, right? Since the rate over here is given in terms of seconds, right? So finally, putting everything into the calculator, we should get a value of 2.8 times 10 to the power of 20 neutrinos. And so this is the number of neutrinos that is actually coming from the sun through this ceiling.